Welcome dear students to this exciting journey into the world of PCB design using KiCad, where we will be learning the art of creating printed circuit board from scratch. We will cover topics from basic to advanced in our journey. We will discuss different rules to keep in mind while designing the PCB. As we move further into this journey, we will learn how to design PCB for high-speed signals as well as high-voltage application. So let's just start our journey into the PCB design world. First of all, what is printed circuit board? A printed circuit board is a flat board made from a non-conductive material, often fiberglass, that is used to mechanically support and electrically connect electronic components using conductive pathways, tracks or traces etched onto its surface. PCBs play a crucial role in modern electronics by providing a platform for assembling and interconnecting various electronic components in a structured and efficient manner. The process of creating PCB involves several steps. These steps are: the first one is the design, the second is printing, number third is etching, fourth is drilling, fifth is component placement, sixth is soldering, seventh is testing, number 8 is finishing. So let's discuss these steps one by one. The first step is design. The circuit design is created using specialized software. This involves placing electronic components such as resistors, capacitors, integrated circuits, etc. on the board and connecting them using traces. In the design process, the first thing we create is the schematic. And after we draw our schematic, we will build our PCB layout. The next step is printing. The circuit design is printed onto a thin copper layer bonded to non-conductive substrate. This creates the conductive pathways that will later carry electrical signals between components. Number third is etching. In the etching process, the excess copper that is not part of circuit design is removed through chemical etching, leaving behind only the copper traces that corresponds to the desired connection. Number 4 is drilling. Holes are drilled into the board to accommodate component leads or pins. These holes are often lined with metals to create plated through holes, which enhance the board conductivity. Number 5 is component placement. Electronic components are mounted onto the board using soldering techniques. Surface mount components are soldered directly onto the board surface, while through-hole components are inserted into the plated through holes and soldered on the opposite side. Number 6 is soldering. Solder is a low melting point metal alloy is used to attach the components to the PCB and to create reliable electrical connection. Number 7 is testing. The assembled PCBs undergoes testing to ensure that all connections are properly made and there are no short circuit or open circuits. Number 8 step is finishing. The PCB may undergo additional process such as conformal coating to protect against environmental factors, silk screening to label components and traces, and surface finishes to prevent oxidation of copper traces. Next, we will discuss types of PCBs. PCB come in various types, including single-layer printed circuit board, double-layer printed circuit board, and multi-layer printed circuit board. As the number of components increase in the circuit, we add more layers to accommodate our circuit. Multi-layer PCBs can accommodate even more complex design by having multiple layers of copper separated by insulating material. This is the single-layer PCB in which there is a single copper foil layer onto a substrate. Here you can see a double-layer PCB that has two copper layers, and between these copper layers is substrate. This is the multi-layer PCB. It has multiple layers of copper. Overall, PCBs are the backbone of modern electronics. PCBs helps the creation of compact, reliable and efficient electronic devices ranging from smartphones and computers to medical equipment and automotive systems. Our main focus in this course is to gain knowledge about the PCB design using KiCad. Next, we will see the installation of KiCad on our system. Thank you for joining this course.